we've talked about the difference between elements and compounds. Elements cannot be broken down into simpler things. Compounds can be broken down into elements. Well, there's different kinds of elements. So both elements and compounds are classified as pure substances. Elements can be either atomic or molecular, and this is describing what the particles are that make up the element. Most elements are atomic. They're just composed of individual atoms. But some are molecular, meaning that they actually form molecules. So oxygen is an example. If you are able to look at the oxygen gas that's present in the room, you would not see individual oxygen atoms, you'd see oxygen molecules. It's kind of like these guys want to use the buddy system. They only go out in pairs, right? For compounds, we can have molecular compounds or ionic compounds. Again, it's based on what are the smallest pieces. For a molecular compound, you have individual molecules. For an ionic compound, you have individual ions, and we're talking about a formula unit instead of a molecule, because ionic compounds don't actually have molecules. So most elements are atomic elements, but there are 7 molecular elements that I want you to know. The 7 diatomic elements are those guys. Diatomic meaning 2 atoms. So all of these will go out in pairs, when they go out as an element. There are some other ones like P4 and S8 that have molecules of atoms within the element, but I'm not going to test you on that. So how can we remember those 7 elements? The 7 elements we need to remember are these yellow ones. I'm not sure what color that is. The peach, light orange, something like that. Salmon, yes. So those exist, but we don't have to remember that. We do need the yellow ones. So if I start at the 7 and make a 7, I've got 6 of them. The 7th one is hydrogen, the baby brother who breaks all the rules. So he's off in La La Land while the other guys are over here. So that's one way. Another one is a silly sentence called a mnemonic. Horses need oats for clear brown eyes. And it works out really great until the end. It's Br for bromine, Cl for chlorine, F fluorine, O oxygen, N nitrogen, H hydrogen, H horses, H hydrogen, for clear brown eyes, like seeing eyes, right? So anytime we see one of these elements by itself in a chemical equation, the formula you write is with a 2, so H2 or F2. This does not apply if it's part of a compound. So I think of these elements as maybe being a little skittish of being out, they don't want to go out alone, right? Just like you shouldn't go swimming alone. You should use the buddy system, right? So you should go always swimming with someone else. So these guys maybe are following the rule about not swimming alone, and everybody else is throwing caution to the wind and going off by themselves. But if nitrogen or oxygen is involved in a compound, then it's not by itself anymore, right? So it doesn't need a buddy of its own element kind. It is swimming with other things. That one just kind of got made up right now. So molecular compounds have molecules, and these are composed of 2 or more covalently bound nonmetals. The ionic compounds, we have a metal and a nonmetal. Water, dry ice, propane, these are examples of molecular compounds. If we look at their formulas, the elements in them are nonmetals. Do you remember how to tell which is a metal and a nonmetal? There's that stair-step line, and the elements to the right are nonmetals, and everything to the left is a metal. Ionic compounds, a metal and a nonmetal. And it says usually because there are exceptions. So the basic unit here is the formula unit. And that's just a little hard to describe or explain. In a molecule, you have maybe a molecule's like a family, right? And there's people that are part of the family, and they've got friends and stuff, but the other people aren't part of the family. And so maybe water might be like 2 parents and 1 child, or 1 parent and 2 child, and that's the family unit, right? In an ionic compound, there are no family boundaries like that. And so you just have a ratio, say, of adults to children in this big group, and the group could change in size. We don't know or even care exactly how many ions are in that chunk of stuff. What we care about is the ratio. I don't know if that helps or not. But in sodium chloride, it's 1 to 1. And so the formula unit is just what's in the formula. Any questions? Then there are polyatomic ions. So polyatomic means more than 1 atom. And so we've got 2 or more atoms that together have a charge. These atoms are covalently bonded to each other, but overall they have a charge. So examples of this would be NO3 minus. This is one thing with a charge. And we will talk more about those in a couple of minutes. We need to be able to classify elements and compounds, especially compounds, so that we can use the appropriate system of naming for them. So we'll practice that. So fluorine, we're looking for atomic element, molecular compound, or ionic compound. Atomic element is a good guess. Molecular element. So this is one of the 7, right? Fluorine. So this is a molecular element. And that's they have to give you its name instead of its formula, because the formula would be a dead giveaway. It's F2. Okay. N2O. Here we have 2 element symbols, so this obviously is not a single element, it must be a compound. Is it molecular or ionic? It's molecular because nitrogen and oxygen are both nonmetals. And the way you know that is you look at the periodic table. We look at the periodic table a lot. So this is a molecular compound. What about silver? That's an atomic element. So silver is one of the elements on the periodic table, and it's not in the group of 7. So it's an atomic element. Did you see what I did there? Atomic silver. Atomic element. Oh my word. So its symbol would be Ag. How about K2O? Ionic. So this has potassium and oxygen. Do you think of potassium as being a metal? No, you don't, right? My husband's been talking about needing more potassium in his diet. Potatoes have a lot of potassium in them. Potatoes have metal in them? Well, metallic ions. When it becomes an ion and part of an ionic compound, it has very different properties than it does as an element. So K here, the way I expect you to know that it's a metal is that you find it on the periodic table. Right? It's way over there on the left side. Metal, non-metal, ionic compound. How about Fe2O3? Ionic. Iron is one that we more easily recognize as a metal. Any questions?